Hello?
Hello.
All right. Okay. Now, good morning. Konnichiwa. Dankeschön. Owa. Ohio. Is that right? Ohio? Or is it Ohio gozaimasu? I don't know.
What about Arabic?
La. Islas. Yeah, that's only my two phrases that I know. It said no and sit down. That's the only those are the only two phrases I know. So yeah. What is it in Arabic?
Good morning,
Good morning. Let's do a good morning.
Sabah al
Sabah khair.
Sabah
Sabah
al-khair.
latea.
Khair.
Latea. Sabah la khair. Okay, good. All right. So now at least someone learned something, even if it's not math related here. All right. So we're taking a look at this right here. Ah, crap. I gotta line it up again. All right. Okay. So we have another one. All right. What do we got?
Walitanesi.
I don't know that one.
It means good morning in Nahuatl.
In what?
Nahuatl.
Nawat? What's Nawat?
The original language of Mexico.
Now what? What?
Nahuatl.
Now what?
Nahuatl.
Now what? I don't know. Okay, so a little bit of Hangul, a little 안녕하세요, or yeah. Anyway, so given the piecewise function defined by this, determine if f prime exists. Now, here is a basic, the big concept that goes along with this. They don't ever say it specifically. For something to have a derivative at a certain point, okay, it has to have a gradual change. It cannot have a direct change. If the left side is negative and the right side is positive, then it would not be. That would be a pointy point. That would be a sharp end. So at that point, think about at that point, I cannot find the slope at the edge of a knife, right? Because it's balancing somewhere on there, right? So that would be what I refer to as a pointy point, okay? So it's got to be a gradual. The slope has to go to 0 first and then change directions. It's got to do that. So if I have a function that goes positive, okay, positive, and it has to go to 0 first, and then it could change direction to negatives. But if it goes positive, then negative, that means that is a pointy point, and I cannot find the slope at a point. Okay, I can find the limit at the point. I cannot find the slope at the end of a, at the edge of a knife. Is that what you're asking?
Yeah, it wouldn't be 0.
Yeah. So, but right there, just the concept-wise, because the edge of a knife does not have a slope, because you could balance on top of it, but it's not really going to have a slope there. Okay, there's not going to be a slope there, so I can't do that. So, and that's what we're going to do with this. So determine if f prime of 1 exists. That means determine if I have a slope at 1, if that exists. Okay, so now piecewise functions are ones that you're going to see that you're going to have to test a lot. So piecewise functions are, those are the big culprits of it changing. Absolute value functions are also big culprits, but you have to be careful. It's only not derivatable, or you can't find a derivative, or you can't find a slope at the point. All other points in an absolute value work, just not at the point. So on this right here, let's plug in positive 1. If I plug in positive 1, what do I get? I get what? Okay, and if I plug in positive 1 here, I get what? Okay, so I get 2 for each of those, right? So that is continuous. Yes, that is one of the big things, especially piecewise. It has to be continuous. Now we have to go through and find the slope of each one of these. Find the slope of each one of these. So from here, I need to do my function. So as my limit goes to 0, so it's the limit as h goes to 0 of negative 2 quantity x plus h squared plus 4 minus, what goes next? What goes next after that? Parentheses, okay, and yeah, just the function, right? So negative 2x squared plus 4. So I should have probably been a little bit more specific on what I was asking for. But yeah, so the function goes next. After that, all that's going to be over h. All right, let's go ahead and do some expansion. So expansion, I get negative 2 quantity x squared plus 2xh plus h squared, close, plus 4 minus 2 plus 2x squared minus 4. I almost messed up there. Where were you at on that one, Friday? Man, seriously. I needed your help there and you left me hanging. Okay, go ahead, do my distribution of that negative 2. So I have negative 2 x squared minus 4xh minus 2h squared plus 4 plus 2x squared minus 4. So I'm going to go through and I'm going to do my little circling thing that I like to do. Actually, let me do this first. H, a little circling thing so I can actually get rid of some stuff. Get rid of this and get rid of this. So all those go away and I'm left with this right here, right? So can I factor an h out?
Yes.
Yes. Let's factor an h out. So I'm going to take out an h. So I'm going to be left with h quantity of negative 4x minus 2h all over h. And by doing that and taking this limit, there's my removable discontinuity, so I'm going to cancel that bad boy. Bam, bam. Now can I take the limit? So yes. Yeah, so I can go that h is equal to 0, right? So I could plug in 0 for h. And it's going to give me what? Say negative 4x. So I get, so that one's going to be f is going to be and at positive 1, what do I get? Okay, so I'm going to do another one for the other side. Insert. So the other one was what? X squared what? Plus 1? Okay, so let's go ahead. So if you notice, I noted, so this is my first one. The other one's my second one, so I could actually keep track of which ones we are doing. Alright, so let's go ahead. So it's going to be limit as h approaches 0 of x plus h, close, squared, plus 1 minus quantity x squared plus 1 all over h. So I get x squared plus 2xh plus h squared plus 1 minus x squared minus 1 over h. So color coordinating again. Get rid of my x squareds plus 1 minus 1, so I'm left with, I can factor out an h here also. H quantity 2x plus h, right, all over h. So I'm going to get the limit is going to be what? So I could say f prime of the second one of x is 2x, where f prime of the second one at 1 is going to give me, because I'm plugging in 1, right? Yes? Okay, so what does that mean? So I have two different slopes from that. So the first one right here is, come on, there we go. All right, the first one is going to be -4. So the top one, the slope is going to be -4 at that point, where the second one is going to be +2. So it's changing. So at that same point, I have two different slopes. So that one is not going to be differentiable at that point. Now, I will show you by showing you the graph. So I will. Come on. Oh, crap, it's over there. That's why. So I want to show you guys the graph on this. So we're going to graph this. So I'm going to enter a piecewise right here. And it's a 2-piece, right? What was my numbers? -2x, right? 2x squared plus 4, and that's when what? When x is control equals less than, right? It's not equal to, right? Less than 1?
Yeah.
Okay, so let's do the next one. X squared, so x squared plus 1, where x is going to be, okay, so control here. Alright, so now, you guys doing this yourselves, this piecewise thing is important. Knowing how to plug in a piecewise in your calculator is super important, because if you're trying to use a TI-84 on this one, that one kind of sucks. Okay, because I tried it and it's really a pain. Anyway, but this one actually has the tool to do it right away. So I'm hoping you guys are paying attention, maybe even taking a little notes on doing this one on the graph. So, anyone struggling with this? Yeah, what's up? Hit tab. There you go. And it's right here. It's right next to the book. So if you guys are looking for the tool to do it, you have to go to the graph. Okay, you're not the graph. So go to the graph first, and that's where you enter. So here, there you go. Anyone else? Anyone else? Struggle is real. Alright, so I'm going to go ahead and enter this now. There we go. So at 1, what is it? Yes, that is my pointy point. So at that point, I have two different slopes. I have a positive and a negative, so it's changing. So I need to have a gradual. So both of those, for this piecewise to work, I would need to have the same slope from both sides. I would have to have the same slope from both sides. Or one, if I'm trying to graph it, like if it says x is going to be less than 1, that means it's got to like somehow gradually change, you know, from one to the other. But this one right here is my pointy point. I cannot take a derivative at that point. I cannot get the slope at that pointy point. All right, so the term that we're going to use for my pointy point is a corner. It's going to be a corner. But by describing it as a pointy point, most people remember that because it sounds funny. So it is called a corner. So on the AP exam, if you are going to refer to it or actually, label it, that is a corner.
Well, I'm pretty sure they don't enjoy it.
They do, but they do not give you the point for it. So you do not get a point for the pointy point on the point.
It's worth making them
Showing that this function has no derivative, show that this has no derivative at 2. Can I do that?
Wait, no.
Okay, so we can go through, we can do the math for it, it's the same thing, right? So what is the domain of this? Is all real allowed here? What's the root on this?
To the fifth, so it should be.
Fifth root, right? So fifth root should be allowed, shouldn't it? Okay, fifth root should be allowed. So do I have any domain restrictions? I'm allowed negative inside of fifth root, right?
Yeah.
Okay, I'm allowed negatives. Okay, so it doesn't look like I have any restrictions. Okay, let's show this one. So from here, I need to go through and I'm going to do same thing. Oh, crap. No. Yeah. This right here is some serious algebra.
Yeah,
The algebra has to be strong with this one to get this. Yeah. Really close. Really close. But it's the conjugate for this one is actually interesting.
you multiply by the derivative.
Because this one's going to be,
Yeah, conjugate. What?
think of it like this.
Okay. Part?
You complete me.
Yeah, so you.
How do we complete that?
Conjugate, right?
Yeah, but how would I complete it though? How would I complete it? What power will complete that?
Like it has one, so like this side here.
To the what?
1/5.
1/5.
Because when you're multiplying, it should add.
Yes. You have to make them complete. So right here we have 4/5 and need 1/5 here, right? To complete it. So, but it's still going to be the conjugate, right? So that means I need to have what symbol next? Plus sign. So as I distribute this, the conjugate should go away, right? The middle term should go away. So my first term should be x plus h minus 2, right? Then it's minus my other side, which is going to be x minus 2, right? Over yes? No.
Wait, well, more than H, right?
No, I'm making sure everyone's following along because this is some like special math here. This is yes. It's going to. It's going to. I just didn't put it down there yet. So yes, thank you. I didn't put it down there yet. I'm just making sure you guys are understanding what I did on top. That's what I was worried about. So that means it's going to be all this. Because I got a bunch of weird faces when I did this. More than normal. All right, so what's going to happen on top? I get a negative x, and I get a positive 2, right? So it's going to be 1 over as h approaches 0. So as h goes 0, I'm left with 1 over, I get 2 of these, right? They're both going to be the same. X minus 2 to the 1/5. So what we're saying now is that f prime of x is equal to 1 over 2 quantity x minus 2 to the 1/5. So that is the equation of the derivative. So that is what I would plug in. I would plug in into that to be able to find the derivative or to find the slope. Yes. Where did I get the 1? Okay, so on top right here, on top as I distribute this, right, that becomes positive, that's minus. So I distributed it here, right? So now a negative x, positive x, negative 2, positive 2, so I'm left with h, right? So h on top and h on bottom, I took those out. Okay? So is there a derivative at 2?
No,
Why?
because you can't have 0. No.
I cannot have 0 in the denominator because I have f prime of 2 gives me 1 over 0, which is undefined. So, a lot of special algebra went into this one. Okay? And I had to use my Jerry Maguire joke on this one. You complete me. You had me at hello. Anyway, was it parentheses? X minus 2 close caret 4 over 5? 4 over 5. So at 2, there it is. So I could take a derivative at any other point. I could find the slope at any other point except for at 2. That's the only problem, because the restriction on the domain is at 2. Okay, and that's only restriction when I have it in the derivative. So it's not in the function, it's only in the derivative. All right, so let's see what we got next. So here's another one where it's not going to have this have any horizontal tangents. Yes. Explain why and identify where it occurs. This one's going to be at 0. There is a vertical tangent. Okay, there's my tangents. Does the graph have any vertical tangents? Yes. Where? Why? Does the graph have any corners? Explain yes and why. This one right here, what other information do I know about this one? Is it continuous? It's not continuous. You cannot take a derivative at a non-continuous point. So I cannot do that at 2. So I could find the slope from anything less than 0. I could find the slope at from 0 all the way up to 2, but not include 2. And I could also find the derivative or the slope from 2 on to infinity. Okay, those are important. And I think that one was last. Right here, yes.
Can you find the slope of 0?
No. It's a tangent line. It's a not a tangent line. It's a asymptote. If it's an asymptote, it actually never touches it. So we're going to talk about that later on when we're talking about equation of a circle. The equation of a circle, I could actually get a tangent line on the right hand and left hand of a circle. It's just going to be undefined slopes, right? Yeah, we're going to talk about those later on, though. All right, there we go. Okay, has to be continuous and differentiable and continuity. It's got to be both. This one right here, it is continuous, but doesn't exist because it is a pointy point right there. That is a corner. Okay, this one right here is discontinuous, so this derivative cannot exist. All right, okay, like, share, and subscribe. Hit that notification button.